Hi, hello and welcome to this lecture on a brief overview of Java. The key point here is brief. This course is clearly not about Java itself, um, but many students come to this course without a strong background in Java, or they have taken Java a long time back, and a quick refresher should help. Okay, so that's the point of this video and this lecture. We are not even going to, we'll barely scratch the surface. There is a lot more that is remaining. And if you are still not confident or comfortable with Java, um, I recommend picking up a book or looking up the Java documentation, right? Okay, so suggested reading, some links from the Oracle Java tutorials, and as I said, any good Java book. So what is Java? Java is a programming language that developed in early 1990s. So, more than 20 years old now. Um, it, the work on this language started at Sun Microsystems. Now it's part of Oracle. Language is based on C, C++. It has very similar syntax, very similar control and data structures. Um, Another language that is sort of similar, which came later, is C#.NET. So people who are familiar with that should find adapting to Java fairly easy. Like C, C++, this is an imperative language. And like C++, it's an object-oriented language. It's a fully object-oriented language in the sense um, everything has to be part of a class or an object. Um, so even the main function has to be enclosed in a class, for example. Okay. Um, Java was originally being designed for interactive television way back in 1990s. And as it happens with a lot of inventions, you try to do something but end up getting something else. So a famous example is the post-it notes. People who invented post-it notes were actually trying to develop a very strong sort of a permanent glue, but their research, their work ended up giving us something that is a temporary glue, a very temporary glue. You put something on it, put the note on the refrigerator for your roommate or someone else at home, and they look at it and immediately remove and throw it away. So um, these things happen in invention all the time. Java is also an example. So instead of interactive television, it found its initial success in internet application because of its portability. Later, it was people started using it as a general purpose programming language, and that's where it is. It is also used as a fairly common introductory programming language in computer science courses almost all over the world. Um, there is some criticism of Java, of course, but yeah, there are certain good aspects and some foundations that Java laid um, are are still relevant, um, and Google chose Java for some of those reasons. Okay, mainly portability, in my opinion. All right, so we'll come to that in a second. Um, yes, JVM, the Java Virtual Machine, is the key aspect of the Java ecosystem. Um, and its slogan, Java's slogan was write once, run everywhere. So the key point here is, before Java, you can imagine a C-like program, and if you have to run the program on another machine, you have to compile it for that machine. Java essentially removes that requirement, with a clever use of a virtual machine. So let's look at this figure over here. You start with a source code hello.java, compile it to hello.class, what's called a bytecode, hello.class. Now this dot class is not a machine code, it's a bytecode, and it's called bytecode. But it's a code that the Java virtual machine understands. And Java virtual machine is a piece of software installed on top of the actual hardware and OS, and it's that layer which is executing your program. Um, so as long as you have the right version of the JVM, it does not matter what hardware or OS you have. You can have the same program run on a uh, Windows 10 on say an um, on a 32 on a 64 bit computer, and as long as that JVM understands that translated .class file, it just works. The same version of JVM, if you have installed on say Ubuntu Linux on some other sort of a machine, again, as long as you have the same version of the JVM, um, rather compatible version of the JVM, the .class file will execute on that JVM irrespective of the hardware. So that is the portability aspect, and that removed a lot of requirement of compiling the code again and again, depending on the hardware and creating executables for a specific hardware, and that was the key success of Java. The second point, universality, also relates to this aspect of JVM. Um, JVM sort of becomes this universal intermediate machine, and if you can translate your program to that JVM, then you can take advantage of existing JVMs, which are more or less ubiquitous, and compile your source code in a different language to that. So, Kotlin, for example, or Scala, you can write in a different high-level language, but compile it to the bytecode that the JVM understands, and you have universality of different programming languages compiling to your machine. Um, and surprisingly, the third major bullet point here, performance. So this extra layer comes at a surprisingly small penalty in performance. Now, this statement is perhaps will perhaps be contested, and Java is significantly slower than C, for example. Um, but compare it with some other um, object-oriented languages, and especially with advances in hardware, the penalty in performance is, I wouldn't say negligible, but definitely affordable, given the advantages of portability and universality. Right. So that's a brief background of Java.